My presentation topic is finding maximum independent set using ACO-GA algorithm. Maximum independent set is a crucial issue in the distributed system. Maximum independent set is used to finding the largest independent set in a graph, and there are 8 number of open problem in distributed system, in which maximum independent set is one of them. These are some outline of my presentation. Introduction. In introduction part, I will discuss about the independent set, maximal independent set, and maximum independent set with the help of examples. And I will discuss about the challenges in maximum independent set and motivations. Then I will discuss about the problem formulation, literature review, and algorithm, and the methodology of my proposed algorithm. Now, introduction part. An independent set is that in which no two adjacent vertices are adjacent to each other, and maximal independent set are those set which not violating the independence property. Maximum independent set is used to finding the largest independent set among all the maximal independent sets. Let us suppose we have a graph G in which we call the vertices and we call the edges. We have 5 vertices. We can select any node for our maximal independent set. Let us suppose if we select node 1, then remove the adjacent vertices of the selected node, like 2 and 4 are removed from that node, selected node. So the remaining nodes are 3 and 5. We can select any node from the remaining node, like we can select we can select node 3, or we can also select node 5. If we select node 3, then remove its adjacent vertices, like 2 and 4 are removed from that selected vertices. So the maximal independent set is 1, 3, 5. If we select node 2, then remove its adjacent vertices, like 1 and 3 are removed from that selected node, and the remaining nodes are 4 and 5. We can select any node from these remaining nodes. Like if we select node 4, then remove its adjacent vertices, like 1, 3 and 5 are removed. So the maximal independent set for node 2 is 2 and 4, or 2 and 5. Similarly, for node 3, our maximal independent set is 1, 3, 5. For node 2, maximal independent set is 2 and 4. And similarly for node 5, the maximal independent set is 1, 3, 5, or 2 and 5. So the maximal independent set in this graph is 1, 3, 5, 2 and 4, 2 and 5. So the maximum independent set is the largest one from among all the maximal independent sets. So the largest set is 1, 3, 5. So the maximum independent set in this graph is 3. Why is maximum independent set is a challenging problem? Maximum independent set is a very difficult problem to solve. It is an NP-hard problem, and we cannot solve this problem in a polynomial time. It is a very difficult problem for the large graph. As we see in the previous example, in this graph we have only 5 nodes. And we can easily find out the maximal independent set or maximum independent set with the help of brute force approach. But when our graph will increase gradually, or if we have graph like 1,000 nodes or 2,000 nodes, or in lakh nodes, then it's very difficult to find out the maximum independent set. Then we need a different type of techniques to find out the maximum independent set. So we can use a different type of techniques to find the maximum independent set, like we can use the approximation technique, we can use randomized technique, soft computed technique we can use, or we can use the exact algorithm to find the maximum independent set. These are some motivation. In this different area, maximum independent set is used, like network design and optimization, to identify the non-conflicting nodes to optimize network, or in scheduling case, help to schedule tasks. No two tasks are executed at the same time. In case of clustering, social network analysis, or fault tolerance to ensure the reliability, and train scheduling, like no two trains are occupy the same adjacent track simultaneously, or to avoid the collision. And all over cases like to optimize no two person sharing the same request to the same vehicle. Like these areas, we can use the maximum independence set. This is the problem formulation of the maximum independence set. Let us consider we have a graph G in which we call the vertices and we call the edges. N is the stable set, or we can say that the independent set, where no two vertices are adjacent to each other. Alpha G denotes the maximum independent set, or the size of largest independent set in a graph. That is also called a stability number. As we see in this in this uh, like this equation, maximize xi means independent set. In this case, we add the independent set in this equation. If xi is 0, that means our vertex is not included in that independent set. If vertex is 1, that means our vertex is included in that independent set. These are some literature papers in which some author had proposed their work on soft computing techniques. This is my proposed algorithm, ACO-GA algorithm. In this graph, input is the graph G, colony size is the size of ant, evaporation rate is used, maximum iteration and repetition is used to improve the quality, and output will be given maximum independent set. Firstly, we read the graph. We will take the input from the Dymax data set. I'm using in this paper Dymax data set. This is an online data repository in which there are lot of graphs are there, like in 1,000 nodes are there, or 10,000 nodes. S denotes empty. It is the maximum independent set. Initially, maximum independent set is empty. Then initialize pheromone. Firstly, it initialize the pheromone. All vertex has same pheromone level. Then all ants construct the solution according to the pheromone, and it construct the solution and put into the solution part. And if the it iterate number of all ants iterate for the number of iterations, and it will give the solution, and it update the pheromone according to the solution. If it will give the best solution, if ACO will give the best solution, it update with their solution. Then I am using GA algorithm. GA algorithm is used for conversion state, because ACO sometime ants follow the same path, so it will stuck in the same path, and it will not give find the other path to for finding the maximum independence set. So I'm using GA here. The output of the ACO will be the input of the GA algorithm. So it follows some steps of genetic algorithm and compared with the solution. If its refined solution is greater than the previous solution, then it will update their solution with the best maximum independent set. This is the methodology for ACO-GA hybrid algorithm. Let us suppose in this graph we have 12 vertices, and some vertices are connected with each other. Initially, for pheromone level for all vertices are same, like 1.0 for all the vertices, and evaporation rate is used to control the pheromone decay. If number of ants using same path, then their pheromone level will increase. If ants will not use that path or that vertex, the pheromone level will decay with their 10%. For example, for started with an empty, it run with for an n iteration with m ants per iteration, and it starts with empty set. Firstly, maximum independent set is empty. Then it select a vertex based on pheromone, but starting it can start with any nodes because all the pheromone level is same. Then remove its adjacent vertices of the selected vertex. It repeats until all vertex are covered. For example, for iteration 1, AND 1 give the solution 2, 8, 6, 5, 10. AND 2 will give the solution 1, 3, 4, 8, 10, 12. Similarly, AND 2 will give the solution, and pheromone level will update according to the selection, deposition, and evaporation. Like if AND using the same path continuously, the pheromone level will increase on that vertex. Then it compared with all the iteration, and it will give the at last it will give the best maximal independent set. Like best MIs for ACO is 1, 3, 4, 8, 10, 12. So in next part, genetic algorithm is used. ACO as an input for the GA, and it start with their methods. Like firstly, it initialize the population randomly and use the parent selection, cross over their mutation and iteration, and give the final solution. It compare with their previous solution with their refined solution and give the best solution for this graph. These are some results. ACO and GA are the existing algorithm, but my ACO GA proposed algorithm give the better result than their both of existing algorithm, ACO and GA. This is conclusion. In this paper, I am using a soft computing technique for solving the maximal independent set, and we compare these results with the DIMEX dataset for testing the algorithm. Thank you. Hello. Thank you, ma'am. Any question?
Hello.
Hello.
Could you hear me?
Hello. Yes, ma'am.
Hello. Could you hear me?
Yes, yes, ma'am. Yes, ma'am. I can hear.
See, you have listed a set of methods in literature for solving the same problem.
Yes, ma'am.
Okay.
Yes, ma'am.
And what is the motivation behind combining ACO and GA for solving the same problem?
Ma'am, in
analyze-
ACO algorithm, sorry, in ACO algorithm, when it starts the path, it will stuck into the same path because aunt will work on the based of pheromone level. If all aunts are the use same pheromone level, they will not check or finding the another path for ACO. So sometime ACO will stuck in same path. So I am using the genetic algorithm there. The output of the ACO algorithm will be the input of genetic algorithm, because genetic algorithm used for the work for the global optima, and ACO for work for the only local optima. And with the help of genetic algorithm, it will work for whole the it will find the solution for all the graph. So I'm using SUGA in in my proposed algorithm.
Did you look at the complexity or the execution time when you combine both of these together?
Yes, ma'am.
Like on what application or what was your test case? How did you
DIMEX
validate your
benchmark data
result?
set I'm using here.
Come again?
DIMEX benchmark data set. It's a online network depository where number of graphs are there, like nodes are 1,000 or 10,000 or in lakhs.
Okay, have you
I compared.
Have you compared your results with those in the literature?
Yes, sir.
What
So
was the
at last I compared these results with previous results, like previous published paper with my proposed work.
no, you have compared your results with ACO separate and GA separate, okay?
Yes, yes,
But
yes.
still, you have listed few more methods in the literature. Did you make an analysis of those methods in solving the problem?
Please, can you please repeat, ma'am?
See, in the presentation, we have listed few methods from literature for solving the same problem. Okay.
Yes, sir.
Did you compare your method with any of those? Like you have greedy approach, you have
No,
some.
no, ma'am. I don't did that. I'm only compared with the ASU and GA algorithm. But in future, I will compare other algorithms.
Okay. Did you try applying your algorithm on any practical applications? What you have listed? Is it part of your research or is it part of your application development?
Research application.
No, because the proposed algorithm, what is the novelty in the proposed algorithm except for combining ACO and GA together for refining the ACO solutions? What is the novelty there? What I'm trying to find out is whether you want to apply these algorithms on this problem and check, or is your focus on refining the algorithms itself? Is it on application or on the algorithm side?
And we can use this algorithm in different areas. Like if we want to send, if in case of WhatsApp, if we want to send message in a group, then we are with the help of this algorithm, we only use some resources because it cluster within a group, and we send one message to one group and it will spread in all the resources. So with the help of this algorithm, we can
Okay.
mhm, yes.
Okay. Any questions from audience? Do you like to-
Hello, are you able to hear
Yes,
me?
yes, ma'am.
Yeah. So while you are combining this ACO and genetic algorithm, so transferring the output from ACO to genetic algorithm, what are the parameters that you are transferring to ACO? Just the final output, or are you sending any other parameters?
I'm using Dimex data set in there, in which large number of large number of nodes are there. So I compare different of nodes are there for finding the Maxwell independence.
Yeah, but so while you are giving the output of your ACO to GA, genetic algorithm,
Yes,
right?
yes, ma'am.
So you are just transferring the output of ACO to the input of genetic algorithm, or are you adding some kind of extra parameters to improve the performance?
No, ma'am. I'm not adding extra performance parameter. I'm using evaporation rate for decay. See how many times after how many times it will decay. So I'm using that parameter only.
Okay, so have you tried with any other methods, combining with any other kind of approach, like greedy approach, any other approach to improve the performance? Like,
Ma'am, I'm using another approach, but in different papers.
okay,
But yes, sir.
okay,
Yes.
okay. So you, what is your performance after the combination algorithm? What is the performance compared to the separate one?
Ma'am, actually, genetic algorithm, if separately I'm using genetic algorithm, it takes a lot of time to run. But when I'm combining both of algorithms, because ACO give the output, and I'm only using that path and finding the another maximum independent set from these only this. If I'm using separately genetic algorithm, it will explore all the graph, and it will take lot of time to run. So I am using the output of ASU will give the input of GA, and GA only work on like output of the ASU, so it will take a less time rather than the existing algorithm.
So the performance is on time complexity.
Yeah.
Okay, thank you.
Thank you, ma'am.
Thank you, Ritika. Thank you.
Thank you, ma'am. Thank you.
Presentation will be by who you have the list? I think one student is there. Shreya. Is there anyone by name Shreya? Shreya's Patel. Hello. Sharvani Patel, could you unmute and start your presentation?
Yes. Yes, ma'am. Good morning.
Good morning. Good morning.
Shreyas, will you please share the screen?
Yes,
Okay.
we can able to see your screen.
Is the screen visible?
Yes, it's visible.
Hello?
Can you turn on your video?
Yeah. Okay, video?
Yeah. Can you?
Yeah.
Yes, sir. Mr. Shreyas Patel.
Hello, sir.
Yes, Mr. Shravani Patel. Good. What about others? Mr. Dhruv, Ms. Preeti, and Ms. Yashodhan. Are they there?
Yashodhan Anand
Yeah,
present.
Yashodhan is there.
Fine. So we want to wait for them or start?
No, Yashodhan is there.
Okay.
We shall continue.
We should start.
You can start
Yeah,
whenever
we'll
you are ready.
start.
Okay, ma'am? Thank you.
Okay. So good morning, everyone, and thank you for taking the time to join this presentation. Today, we, the authors of paper 9, English text to Indian Sign Language translator using Signify algorithm, Shravani Patel, Shreyas, Dhruv, Preeti ma'am, and Yashodhan Ramdasi will be presenting you and addressing you an issue that affects millions but often goes unnoticed. The challenges faced by hearing impaired community in India, our focus will be on how technology can bridge this communication gap, making the society more inclusive for everyone. So, to begin, let's set with some facts and figures that highlights the magnitude of this issue and why immediate action is necessary. So, introduction, it goes as India is home to approximately like 63 million individuals with hearing impairments. Like it includes the people from deaf and dumb society, the people who have means trouble for listening or talking. The sign language is used for them. So despite having the significant hearing impaired population, the resources to support this severely lacking issue are only like means minimal issues are there. So there are 700 schools in the entire country that provide the instructions in the Indian schools, living without formal education, which does not include ISL in that. Even the Rights of Persons with Disabilities Act introduced in 2017, which emphasizes inclusive education, the implementation of ISL as a medium of instructions remains limited and fragmented. This brings us a core problem, the communication gap between the society and the hearing impairments
Sorry for interruption.
communities.
Sorry for interruption. Could you limit your introduction to very brief and then start with your actual technical part of it? Thank you.
Sorry?
you can have a very brief introduction and spend more time on presenting your technical content.
Okay, fine, got it. So yeah, the problem statement states that how we'll come up with the solution to this. So there are 22 schedule languages which will be utilized in our in our problems in our project. Next slide. So further are the research gaps. So research gaps gives us the standardization, resources, technical challenges, accessibility issues, and key questions. We have covered all those gaps and technical challenges which were faced in the previous existing solutions. What were the issues which were there in the previous solutions? We have covered all those technical difficulties, and we have made a more accessible and more feasible project. Further, everything will be explained by Shreyas.
Thank you, Shravani, for the amazing introduction. I'll be covering the whole technical aspect of the project and how we approach this problem and what solution, where are we right now. So basically, moving ahead, ISL has a particular website of its own. So we utilize that to gather its YouTube videos. They have uploaded YouTube videos on the platform, but I have used their web links on their website. So how we did that, we first checked for the word. We did our own parsing structure. The previous parsing structure, which existed, uses WordNet, but it is inefficient because of the structure of the ISL sentence. It is a very simple subject-object-verb structure. And then after that, what we do is we get, for each and every word, we scrap the videos from the website. And for those also, we have implemented our own algorithm instead of using the previous ones, which had pretty web crawling structure and not scraping structure. Due to this web crawling structure, the processing time of the particular algorithm increases a lot by a few minutes, because it would completely go on the website, do the clicks and everything. But for our algorithm that we implemented, the processing time reduced a lot. Then we have also added audio synthesis so that it can be a double check or a checksum verification for your entire video. And then this innovative design is easier to implement and retrieve the video faster. Moving on, do you? Yeah. My bad. Yeah. So methodology, the methodology of the entire structure is basically we first input a sentence that is a proper English sentence, and then the first step is for to tokenize the sentence into particular each and every token. Then we use stop words removal. We remove each and every stop word. That is, this is an R. As we have only 2017 videos in the vocabulary of the ISL, so we don't have that much freedom, we can say. So removing these stop words makes a lot of sense. And then after that, we do stemming, and then we do lemmatization so that we can get each and every dictionary word out of it. And then we realign the grammar structure so as to align, as I have previously said, the subject object verb structure. And then we use our own retrieval algorithm, which is implemented in labs to get these videos out from the website. And then we combine those videos, add audio narration to the text to speech, and finally we get a output generation of a particular complete file. We also take care that the videos that are scrapped or the links that are taken are also hidden, and the particular videos are deleted after usage. So the memory optimization is taken care of. We have used standard libraries such as NLTK, MoviePy, and PyStx3 to convert text to speech, and Stanford parser for parsing the structure. We have used request module for web scraping, and agile. This is a SAS model for scalability, so that anytime if the structure of the ISL website changes, it's not a big issue for us unless the videos are uploaded on the YouTube platform and they are taken from it. This is a practice that I followed for around last 3 years, so we are still confident on the algorithm. Moving on, these are our results. So the translation accuracy is 92%, the grammar consistency is 89%, processing speed is 0.5 seconds per sentence, which is a lot improvement from the previous approaches. And then user comprehension, we from our testing, we got 96%, and error rate is 8% because of the whole, sometimes because of the WordNet limitizer, and sometimes because of the ISL structure not been parsing successfully. So yeah, So on the output, we get a perfectly good video of the entire sentence. And one example is given below. The boy is running fast will be converted to boy fast run, which all three words are in the ISL dictionary and also being utilized. We can see the ISL dictionary of particular maintained properly, which needs improvement right now because we don't have common words like these and everything. But yeah, we have done what best thing that for us. So I'll ask Shawni to cover the references and future work and conclude the presentation for you guys. Thank you so much.
Okay, thank you, Shreyas. So moving with the references and future works, we have developed a system that drew the foundational work in Indian Sign Language, which also helps a significant contributor to domain of Indian Sign Language Research and Training Center, that is ISL RTC, along with the global organizations like World Federation of Deaf. These resources are the insights very invaluable for shaping our approach. Additionally, we have integrated findings from studies on web scraping to enable dynamic data collection, ensuring that our system remains adaptable and with the real-time changes. Further enhancements, we look for real-time translations, incorporation of AR/VR, which will help this education or the schools to run more precisely or can understand the students, teach the students in the reality world without having like 2D communications. User-centric designs, it will have a better UI UX, which will give a better understanding for the students. And ethical considerations, we have also taken care of the laws and ethical considerations without having any plagiarism or having any copies from any other resources. Then in conclusion to our project, it aims to address the critical communication barriers faced by hearing impaired community by leveraging the latest advancements in NLP and machine learning. By acknowledging and building upon foundational ISL research, we aspire to create a system that is robust, scalable, and inclusive. Our focus on real-time capabilities, user-centric design, and legal ethical compliance ensures that tool not only serves its primary purpose, but also promotes social equity. As we look to the future, collaborations with ISL RTC, integration of AR/VR technologies, and ongoing user feedback will be pivotal in redefining and expanding system. Together, the system's efforts hold to the potential foster a more inclusive society where the communication gap between the societies will be covered up. So thank you, team, for your efforts. And Judy, thank you for listening to us patiently and giving us the chance to present.
Okay.
Any questions? Why is this? Can you hear me?
Yes, sir, we can hear you.
You said English language to ISL. Any reason why English you started with? Can it be mapped to Indian languages also?
Yes, sir, we can map it to Indian languages as long as we can identify the structure of the particular language. That's the only requirement.
Because you
Yes,
didn't
sir.
write it as your future work, I thought you'll do that.
Okay.
You'll do that, okay.
Yeah, that would be a great point to add.
It takes certain time for you to map the text to again convert, and basically you're going to access a lot of existing library items to convert, add them into a video, right? It takes certain
True.
time, so it's not really real time. Am I right in saying that?
Yes, sir. We are not doing it right now in real time,
Okay.
but we aim to do that in real time because right now we don't have that much capability of our CPUs also.
Also, it may be too early because sometimes some of the words may not have the right video also coming along. So you have to improve the video library
Yes,
also
sir.
later, right? That may be some
Yes,
of the
sir.
future work.
Yes, sir. You're right.
And hope it's being used already somewhere. And thank you very much for considering such a project. Appreciate a lot. Thank you very much for your participation, sir.
Thank you so much. Thank you so much for recognition.
Thank you.
See, a couple of questions. Like some of the languages are context sensitive. Like when you are tokenizing the input and then looking out for the video corresponding to those tokens. Finally, did you check the syntax, semantics of the language, like context of the language, whether it was translated correctly?
Okay. So, okay, I'll take back to that slide where it shows the entire process of the whole thing. Just a minute. Alright, yeah. So, for to answer your particular question, when you input your text after tokenization, we do parsing, in which we identify each part of the text. What is the subject of the text? What is the object of the text? And what is the verb of the text? And after that part, we arrange that in a parse tree. And then from those parse tree, we take the leaves of the parse tree. And from those leaves, we generate the videos. We don't directly do it, so that the entire process is mentioned in the paper. Yeah.
How do you search your video library?
So basically, ISL has given ISL has uploaded all the videos on YouTube platform already, and what we do is we for the particular word after parsing, we would pay for particular word, which search we scrape it from those ISL uh, website, and we get those links for them, and then we download them from those links.
No, no. You said you have a collection of all the video signs, right? You have the video of all the sign language symbols, right? And for the tokenized text, you're searching that library and picking out the video corresponding to it, right?
Okay, yeah.
Yes? Is that what you're doing?
We have both of them together. For offline dataset, we have offline dataset also, but for online, we have also web scraping the whole thing. So we have mentioned the web scraping part too.
Oh, how much time will it take for searching a video library? Did you analyze it?
Yeah, we did analyze it. For a particular video, let's say only for sentence go, it only took us for around 0.5 seconds. That's the best case possibility. As long as sentence increases, then yeah, our processing time will increase, but also it depends on the network traffic and everything at the later part.
And in conclusion, you said you're using ML. You have used ML. What is the role of ML here?
I don't understand. We said okay, that might be a mispronunciation by my team member. I would sorry for that, but we are not using ML in this project.
You are not using ML for this.
We are not using. Okay, yeah.
Okay, in such projects, ethical consideration is mandatory. It should not be in the future suggestion, right? You have listed it as part of future work, but ethical consideration has to be there every time. Okay.
True.
But this work is in the initial stage.
Is
it part of your academic projects?
Like kind of. We did it for a project in artificial intelligence only, and our professor encouraged us to make it more refined for furthermore. So we did as a best case what we did.
For each of the phases, do you take some tools, integrate it, and then check?
Sorry, I didn't understand.
For tokenizing, you have a tool. Okay. For each of these phases, text processing, you have tools. So you're using those tools and applying these steps?
Actually, no. That's something I covered in my presentation right now. So for tokenization, for tokenization we do, but for stemming and lemmatization we don't. Because if you do it by the tools that are available, that is WordNet Lemmatizer or a Porter stemmer or Snowball stemmer, the words get distorted. Let's say discussed is a word, then it becomes discussed, and as it becomes the word DISCUS, and it is not recognized by the parse tree at that point. It identifies it as a subject at that point. So we have implemented our own lemmatizer so to deal with this particular structure and everything.
What is the largest text you have tested with your application?
Okay, can you give me a minute? I can retrieve it for you because I don't have it time.
You can just tell us.
Sure. I will stop sharing.
But there is no video in your presentation. You could have some clips of your outputs there in the presentation.
Okay, yeah. We should have added that.
That is enough. Can it be a paragraph?
Sorry.
Can it be one-page text?
Yeah. I have. You're testing it yesterday only.
You said it is not on the live text, right? It has to be recorded once.
Yeah. is there an issue?
See, you're mainly focusing for hearing impact.
Yes.
Okay, so you're showing them a video,
Yes.
and you are taking the audio and then converting it to text.
No,
Okay.
no, no, no,
Uh,
no.
what
We
is
are not
your
taking
input?
audio.
What
We are
is your
taking a
input?
English sentence.
Huh?
We are taking a English sentence, a proper English sentence.
Oh, it is not recorded one, right? Recorded video.
No, no, it's not a recorded video.
Then they can as well read the text, right?
Yeah. So the longest text that we took was the accountants manage accounts, calculate balance sheets, and discuss business strategies during annual meeting.
Okay, pay
So the
more
issue,
attention,
oh
pay
yeah,
more attention, make it really usable for the people whom you aimed at. Okay, because if it is like an English text, then they can as well read it.
but it will be useful for your tutors,
It
right?
has to be,
If
it has to
someone else
be,
is using it, then it will
no,
be easy to
no,
adopt it. For the people, yeah, you are right. If they knew English text language and then if they were able to apply it, that's true. But for people, other people, it will be very easier to communicate with.
okay, pay more attention,
Uh,
pay more
Just,
attention.
Shresh, just a minute. I guess I got the question from the ma'am. I'll take it. So, ma'am, what we are doing is I'll give a basic rough view to you now. Totally, we give means users can give English text, and output will be given with the video.
That is what I'm saying. You refine the scope so that your application will be useful for the hearing impaired. Okay, thank you.
Hello. Yeah. So what ma'am is trying to tell is the amount of transition time will be reduced while if you are focusing on that part. I mean, just to English language. That's what ma'am want to convey to you. So focus on that part. And till now, how much is the accuracy? I mean, have you tested for the accuracy?
Yeah, we did, and it is 92%. So basically, 92% is because we only have around 2,447 words in the ISL dictionary right now. So the 8% losses are because the words we sometimes tried and the entire meaning of the sentence will change. It was able to gather the words and arrange the sentence, but the words which are not present, it was able to ignore that, and that's because of the whole thing, accuracy dropped.
So you have tested for the semantics also, like the meaning of the sentence also. It's correct. Is it coming correctly or?
Yeah, it's coming correctly. We do not have issue with that. We are only rearranging the structure, so none of the words are ignored or removed. But yeah, the semantics are perfectly working good.
How did you test that? The accuracy part?
So we had around we made 2,000. We had about 2,000 words. We made a set of around 1,000 sentences, and then we tested in them for all, and we were able to scrap it out of the fine. These are working. These are not working.
Okay, thank you. Thank you.
Thank you. All the best.
Thank you so much. Thank you so much
Thank
for
you.
the submission.
Avni, can you join? Unmute and join.
Yes,
Start
ma'am.
your presentation.
Yes, ma'am, I'm starting. So good afternoon, everyone. I am Avni Gupta, third year BTech student from Thapar Institute of Engineering and Technology. So our topic of research is deep learning methods for suicide risk detection in Reddit posts. So nowadays there has been increase in individuals who usually online make posts before committing suicides. Majorly, they try to express their feelings of distress when they feel that they have no other way to outlet or they don't have any other support system. So we are planning to use NLP to detect the suicide intention in these Reddit posts and correspondingly connect them to government institutes or registered medical help so that the people can get help based upon the online available posts. So our problem is really relevant because nowadays suicides have become a global crisis and such solutions are required for to aid the public health efforts. So our basic framework includes first we'll pre-process our data and involve include which includes text cleaning and like lemmatization, removal of noise and tokenization. Then we'll embed the data using fast text and glove and then we'll apply the model. So basically we have tried different combinations between embeddings and models. Like we use two embeddings, fast text and glove, and use them with different models like GRU, LSTM, BiLSTM, RNN, XGBoost, and Random Forest. And upon finding the various combinations, we found out that GRU along with fast text gave us the maximum accuracy that was of 93.25. So this is our overall methodology. First, we obtained the data. We used an online data set, and then we pre-processed it by converting into lowercase, removing mentions, hashtags, special characters, stop words, short words, and lemmatizing. Then we tokenized it and encoded the class labels that was suicide and non-suicide. Then we included embeddings like fast text and glove embedding, and we trained it on various models and used the optimizer for finding out the accuracy. And finally, we evaluated the model, the various model and embedding combinations. So our main model that with which we received the maximum accuracy was GRU model along with fast text. So in fast text, we found out that because fast text has a special feature in which it can be used to even represent rare words by dividing them into short subwords and integrating them to find the meaning. And in GRU, basically, we used four states like update four gates. So in update gate, we basically decided that what part of the previous content is to be carried over, like retained in the current state. Then in reset gate, we decided what part of the previous sentence has to be forgotten, like removed from the current state. And in the candidate hidden state, we made a combination of both the past and the current hidden state. And finally, in the final hidden state, we created a combination between the previous hidden state and the candidate hidden state. So basically, as we are dealing with long-term dependencies, so GRU model came out to be the best approach as compared to other models. In RNN, we had vanishing gradient problem, hence the accuracy was less. Then in LSTM, that was computationally more expensive because it has more input parameters. So this was our best combination that we found out. The model accuracy was 93.25. The F1 score and recall values are also good. So in our model, as we are dealing with detection of societal intention, so our main focus will be on F1 score and recall values because we want to reduce the prediction of false negatives. So in our future scope, we basically want to integrate our model with an app which can send alerts to registered public health workers. So whenever any individual posts any comment in which there is high intention of suicide, so alert will go to that particular associated public health worker, and they will seek to the individual whether he or she requires help. So after that, it will depend upon that individual whether he or she will respond or not. But initially, we plan to give them support. One of the thing that is important in this project is that ethical consideration, because right now we are not taking any consent from the user, like we are directly accessing their data from Reddit. So in future, we want to include those ethical consideration while integrating our model, as well as we are not saying that we want to replace the human intervention in this mental health aspect. We only want our tool to be a supplementary that can help the human psychiatrist or public health worker. And additionally, we would like to even more reduce the false negative cases, because at times if we incur false negative, then many people who are at high risk for suicide will not get associated to that particular health worker. In all, even though we have used GRU models and there are transformer-based architectures like BERT and GPT, which can give better accuracy and are a benchmark in NLP, but because we had limited resources, so we were not able to implement that, and those can also be implemented in future. Even we can use multiple NLP models together to improve the accuracy of the overall model. So thank you so much.
Okay. Could you move on to the previous slide?
Yes, ma'am.
Yeah, yes. See, here you have, on the left, you have mentioned like analysis of GRU, RNN, LSTM, CNN, and other things. Did you make
Yes, ma'am.
Did you analyze all of these techniques?
Yes, ma'am. I can share you the table. Actually, we missed that in this PPT.
Okay.
We had prepared a complete table in which we have. Just a second. Let me share with you that table. Yes, ma'am. Ma'am, in this we have compared the various combinations.
Which is your method?
We had tried all, and the best one was GRU plus fast text, which gave us the maximum accuracy.
So your work is on implementation of these methods, right?
Yes, ma'am. We tried different combinations, and then the best one was last GRU plus fast text.
So method was not yours.
No, ma'am. We tried various combinations basically.
I know. Okay. Like what was this? What was the input to your work? Is it?
Yes, ma'am. We used an online data set available on Kaggle, which had around 250,000 posts, and it was a balanced data set which included 50 and 50% approx of both suicide and non-suicide.
Okay,
posts.
When you apply this, you said you have an idea of developing an app and use it, right?
No, ma'am. I said that in future we would like to include team members who would help us in developing an application in which, like, whenever a suicide comment is there on Reddit post, so that application will send an alert to that associated public health worker, which can then interact with the user.
Okay. See, normally such cases, you will find them posting messages in some social media websites. Okay.
Yes,
you will have to track. It will not be to one person. They might be sending it to several people, to their friends, contacts, and other things. So how will you track all such messages and then find out the connection between the messages? Only then you can detect the emotions, right?
So, ma'am, we are majorly using websites like Reddit and Twitter where the posts are public. Like they are not only sending, like we are not talking about WhatsApp where they send it to their particular friend, because that is something that we cannot monitor. But in public platforms like in Reddit, whenever somebody posts something, it's a public post. So we are trying to track only those websites where the data is publicly available. But at the same time, in future, we would like to include that consent of user. Right now, we have not used it, use the ethical aspect.
Okay, what analysis are you making on the text sequences to detect their suicide ideation?
Yes, ma'am. So basically, when we are using GRU plus FastText, we are basically in trying to understand the context of the whole post, like whether it is suicide intention or not. So after that, we are trying to classify into two classes,
No.
suicidal and
My question
non-suicidal.
is on the first part. How could you elaborate how you are planning to do that, or you have done it?
Ma'am, and this basically in GRU model is trained, so it will try to use the 4 gates, that is update and reset, to understand whether it is like, for example, if in it is a 2 sentence post, and in the first sentence that person is saying that I am really happy, and in the second is saying that I feel like jumping off a cliff or jumping off my building. So if we try to understand the whole context, then it is not suicidal, because we are dealing with longer dependencies. But when we are saying if that something went bad in my life and I'm feeling like jumping off the cliff, so whole sentence context will be taken.
Okay, thank you.
Yeah, hi, good morning. So, Amni, how did you arrive at this Reddit platform? I mean, what is the reason you have chosen this Reddit platform as your input?
Yes, ma'am. So, like I said, that many websites like WhatsApp and all, there are very private websites and the data is not available. But on Reddit only, the posts are public. So we were able to get the data for that only. Even on Twitter also, there was some problem with like privacy. But on Reddit, the posts were publicly available to us. And that is the main reason why we chose Reddit posts.
Okay, so what's your future plan? Like, you want to make it an app, and what's your steps for that? What are your steps?
Yes, ma'am. So basically, ma'am, we are planning to include members who know app development into our team, and we plan on proposing the solution to government institutions so that they can reduce the suicide rate in India, so that they can associate some public health workers with our app whenever they can be assigned particular area or particular number of users, and whenever within their group they think that particular user is posting something suicidal, then that particular health worker will directly contact that user, and rest will depend upon the user whether they want to like accept the help or not. But initial intention is to provide them with help.
And do you want to personalize it, kind of instead of a health worker, do you want to add family members or somebody? You want to add somebody from the family rather than the health workers, which will work a bit more faster than the health worker. Do you feel so?
I feel that if a person would have like wanted to tell all this to their family, then they would have done it at the first place. And if a person is posting on social media, then that means that they are not getting support from their family or friend. Even like they are not able to find someone with whom they can talk. So I don't think that we should be telling their family, because had they felt that their family would support them, then they would have not posted on the social media only at the first place.
So, what were the challenges while you were doing this project?
I think the biggest thing is ethical consideration only. Like we are accessing user data without their consent, which is not right. So in future works, our main goal will be to include user consent in this. And secondly, I would say that false positives is also a problem, because sometimes people are actually not suicidal and they are just posting it for fun, like they want some attention from their friends. And sending a public health worker to talk to them is like a wastage of resources only. So that is also an issue.
Okay, thank you.
Yes, ma'am.
Any more questions? You have done suicide risk detection using Reddit posts, right?
Yes, ma'am.
Why
Yes,
was
sir.
that chosen? chosen? Why not any other media?
Yes, sir. So I said, like, in Reddit post, it was a publicly available data to us that had like least security concerns. In other platforms, there were security reasons with which we could not access the user data. So it was the best platform for publicly available data in which we got the maximum examples.
So you may also possibly explore extending it to other platforms. I don't use Reddit. You are from Thapar, right?
Yes, sir.
And did you have any suicide issues in your college?
Yes, sir, that is one of the reasons why we started this
Yes.
project. Like during a second year,
Yes.
one of our, like, not friends, but one of a person who was known to us tried to do it, although he was not successful. But upon talking to all his friends, we came to know that he had expressed his feelings on social media platform, but people did not take it seriously.
Thapar actually had a suicide about some years back, year back or so, and it actually happened. I would sorry to say it's a successful suicide. Apologies for using the word. And the reason given was some placement related aspect. Are you aware of it?
Sir, I am not aware of this one, but the one that I'm talking about was when we were in second year. Although it was not successful, but yeah, it was academics only. The major reason are mostly academics.
Because, ma'am, in your paper, it looked like a lot of theoretical numbers and other things, and I was not sure if it was actually mapped to a real life scenario and possibly an improvement is achieved in the college. Maybe you should look at that as well.
Okay, sir. Yes, sir. Definitely.
Because a lot of them may not even do actually social media platform. There may be other way of possibly tracing it also sometime, right? And we appreciate your good work. I hope you'll make it more practical and real life useful for everybody. And may this never happen. May Quota actually start using your product soon. Thank you.
Yes, sir. Thank you so much.
Thank you. Anybody else? Thank you very much, ma'am. You can log out. Appreciate you, sir.
Thank you, sir.
Very aptly poisoned placed. one talk right now is with Mr. Vinesh ji, how when we talked yesterday, we attended about the GPUs, how they work and so on, which are important for the generative fabrics. But importantly, originally the GPU itself was not meant to be for this. Later on, it was because of a Stanford paper and so on that it can be used for AI, that's how it started. So how do you position a GPU fabric for a Gen AI requirement? It's a very important consideration for many of the system architects, is what is going to be talked to by Mr. Mineshji. Thank you very much for coming, sir. He's from Vadvani AI Foundation, and we'll have his talk now. After that, we'll sign off with a reflective thought on what exactly are the requirements. We're talking about responsible AI. So what exactly are the requirements, safety requirement, ethical requirements, operational requirement for planning the such as systems, AI system concept. That's how we're going to sign off. The next talk will be that, so that we'll go back with, after all the knowledge, mapping to how we can start mapping to our responsibilities in the domain as a student, as a teacher, as a practitioner. So with that, we'll give it to Dr. Minesh ji. Thank you very much, sir. Appreciate your support.
Hello, am I audible? Okay. Okay, one second. Yeah. So hello everyone. My name is Minesh. I work as a machine learning scientist at Vadvani AI. I've completed my PhD prior to joining Vadvani AI. So I'll start by talking a little about our institution. So Vadvani AI is a not-for-profit institution working we work in the field of development sector. By development sector, we mean developing solutions, AI-based solutions for the social good. Our stakeholders, our partners are mostly from the government sector, and we also work with other NGOs in this space. And we ensure that our innovations reach the people who need it the most. So we work in domains such as public health, agriculture, education, and urban development. So I'm certain you might have had at least 2-3 sessions on responsible AI. And here I would like to differentiate between responsible AI and the responsible use of AI. So like in the previous sessions, you might have heard about various principles and practices in responsible AI, how to make your machine learning system or model more robust, more fair, and like how to use data more ethically, how do you avoid any biases in your data. But like what exactly is the responsible use of AI? So here we talk about a military application of AI. Say like you can still build follow all the responsible AI principles to build an image recognition system for to use in say military drones. It would be fair, as in it may not differentiate based on gender or race, but it cannot be considered as a responsible use of AI. So what is ingrained in our vision is to build systems that use AI responsibly. So there is a slight difference in like what is responsible AI and the practices and theory in that space versus what is responsible use of AI is. So our primary focus is large-scale social impact. So our vision is to use AI responsibly, and the responsible AI practices or theory helps us to do it better. So another stark difference, so like I come from an academic background. So when I joined Vadvani AI, So the primary, difference, or like the primary learning was to like move from the lab setting to the field setting. So, and this is applicable for any technology. Like you always say the lab is different, and when you use it in the real field, it's quite different. So you cannot probably take all your learnings from the lab to the field setting. And what exactly is the real world here? So like real world has probably two definitions. When you apply an ML algorithm in the real world, what you call as real world. One is the world we live in, and probably the one is where like most AI algorithms operate. But in the global south, or in the developing, in the context of developing countries, these need not coincide. And also the real world for you or me, like for most of us in this room, is entirely different from the real world where Vadhvani AI needs to operate. For example, in Indian context, the real world where Vadhvani AI needs to operate is the place where like at least one farmer commits a suicide every hour. At least one railway worker gets killed, not by accident, but because of lack of safety measures. And people dying of TB, like we account for almost 1/4 of the TB cases and TB deaths in the world. But we know how to cure TB at least for last 50 years or 100 years, but we still have deaths from TB. And we are one of the, in the malnourished children status, like we always top the list, maybe even comparable to sub-Saharan countries. And although we have a food surplus. And there are like high school children, there are various studies that shows that even, children who are 15 plus cannot read in their mother tongue. A grade 2 textbook, they cannot read in their mother tongue. So this is the real world where our institution need to operate. So this could be totally different from the world I imagined while solving or like building AI solutions when I was in my academic lab. And this is even different from the reality I currently live in. So the characteristics of our real world, it's messy, dynamic, it's poor and rich at the same time. And the data readiness, see, like if I want to develop an AI solution for something in real world, you always need data, right? And most of the time, say like for example, if I have to develop something in the public health space, there must be some digital data for me to work on. But most of the times, we don't even have moved to electronic health records yet. So unless I have electronic data, I cannot use my AI algorithms on top of it. Similar situation, say like if you want to build an LLM for information retrieval in the code settings, most of our code records are still paper-based. So the data readiness in Indian setting is very bad. Then we need to get labeled data. Like for training any machine learning model, most of our ML algorithms are supervised ones. So you need training data. So there is an image, you want to probably label it as a cat or dog. If there is a text, you want to probably assign topics to it, whether it's sports or politics. But such labels, when you move to Indian context, for example, if I want to build a screening tool for TB, how do I get labeled data for training my ML model? So that's a problem. And when it comes to deployment, internet connectivity is a problem. So you know that most of the models currently, like the deep learning models, they're at least a few MBs in size, and you probably can't run it on your phone. You need a GPU for the compute. So mostly your compute will be somewhere else. So you need internet to send your data from your phone to the server or to the cloud. So internet connectivity is an issue. And the user, so we don't have deployment platforms that are contextualized for the Indian culture or Indian setting. Say like the kind of platforms where you need to deploy these solutions. Are they designed taking into consideration of the reality in where we need to operate? Say like an ASHA worker needs to use this, or the frontline health worker who's different from like what you imagine as a healthcare solution. Maybe you would imagine a doctor would use it. No, like here in Indian context, when a frontline health worker means somebody like an ASHA worker who is not used to probably using smartphone like you imagine in the West. So another problem is you need a lot of competent partners to roll out. So like we as an institution cannot do every aspect of a solution deployment. We are like a 200-member organization. So like if I want to deploy a solution somewhere in Karnataka tomorrow, I need a partner there who can help with this deployment. So these are some of the characteristics of the real world where we need to operate. Yeah. So I think like most of you are from the academic field. So like in academic space, ML research typically means you have a data set there, out there. Somebody released a public data set, wrote a paper, and there is a public benchmark data set. So for example, if you're doing image recognition, there is ImageNet or MS COCO data set on which you need to uh, build an algorithm that beats the best or the state-of-the-art results on that for that data set. So your objective is always, okay, the data set is given to me. Somebody has created a data set. I don't have to worry about whether the data set has, it's well distributed, whether it's bias free. So it's not my concern. My concern is only to get the best accuracy on that data set. And the metrics I use is, okay, these people use a standard metrics. So if image recognition, it could be precision, recall, or accuracy. These are the metrics everyone use. And for me to get the paper published, my objective is to get results better than what the other guy has reported. So the iteration only happens in the algorithmic experimentation. So you've taken a CNN model, or maybe you have used the recent vision transformer to train your image recognition model. So I keep trying models. I may change the layers, I may change the hyperparameters, or maybe I even come up with a new neural network architecture that can give me best results. So my entire objective here is to write a paper by saying that on this God-given data set, on this God-given metric, I'm the best. So when it comes to ML in real world, so this is even applicable from the responsible AI point of view. The first thing you need to use, we see it a lot when we talk to companies and people who want to use AI. We tell them the first thing you should ask yourself is whether I need AI for this problem. So that's the first thing. You should use AI only if AI is needed there. Something that can be solved by a program, or something that can be written as rules and just you need to apply rules for something. You should not use AI there. So that's the first thing you should ask yourself. Second thing is probably you should understand for whom you are building it. So different from academic setting where you need to get the right numbers on the data set. Here, even if you have a good image recognition model, or even if you have a text classification model, it need not translate into your program output. Say like I am building an image recognition model for a medical disease screening. Although like my model has the best performance, if it fails at the program end, suppose the ASHA worker fails to use it, there is some resistance from the ASHA workers to use this app because your application has a very bad user interface. So it fails technically. So yeah, so you need to understand the deployment environment and you should respect it. So it's not like, okay, policymaker at Delhi tells you, okay, we need a new app for ASHA workers, so you start building it. No, he or she would say you need to build an app, but who is it built for? You should talk to that user first. So that's why it's important to have a user research team within your institute. Yeah, so other thing different from the academic setting is you need to iterate on not just the model. So you're not like trying different models. You need to iterate on model, data, and even sometimes problem definition. So there are cases when we try to model a problem as a regression problem, and after 5-6 months, we probably like realizing the ground, what is happening in the ground, we realize that no, like we probably might need to switch it to a classification problem. So even not just your model, even your problem definition can change over time. Yeah, so like we have seen the earlier figure, which is for an academic setting or like ML research. And when it comes to the real world, where you actually need to deploy solutions for the development sector, so this is how it looks like. So you can see that here we iterate not just on the algorithms, you need to iterate on maybe the pre-processing and the transformations of your data, maybe you need to collect additional data. There is some metadata that can probably help with your decisions. It's not just that, okay, there is an image recognition problem, I just use the image as features, but like what if you can use some data about the symptoms of the disease along with your images to make a prediction. So the metadata could be really useful, not just for making the model, but in some cases, you want to probably make an analysis of the results. Say like, I have an image-based screening tool, but how does it perform based on gender or geography? So unless you collect the metadata, you will never be able to look into or like analyze the results each cohort wise? How does it perform for each age group, or how does it perform for each gender? So it's important to collect the metadata. Then very important thing, the user interface design. Like I said before, you should have very intuitive design that that matches with the cultural context where you operate. So suppose like maybe it's about the making it available in the local language, or make something that is similar to the apps they are familiar with. For example, a person who is not very familiar with all sorts of apps that you get to use, but maybe if she or he uses a smartphone, WhatsApp in their smartphone, and if your AI chatbot can be fashioned in a similar manner, it will be more intuitive or more easier for that person to use it. Yeah. Once you deploy, like say like you have a pilot deployment, then is the real struggle starts. So like we have an understanding that your model developed, the first model you develop, it's always destined to fail, because we always get some data from somebody, a data collection partner or something. Now we go to a certain district and deploy there. We feel that always we claim to have a precision of say 90%. We go to the field, we come to a number like 40 or 50. So because there is drift in data, so there is data drift. The kind of distribution of data I've trained on, the kind of distribution you get in the field is always going to be different. So that's where you need to come back, you need to iterate. So maybe you need to collect more data, more metadata, and iterate on, probably the iteration on the model will be minimal, but iteration on data and the kind of sampling and transformations you need will be more. So instead of in the real world setting, in contrast to the academic setting, what you need to do is probably like here the objective is not to publish a paper, right? So we train the model, and you predict a label, you evaluate, and you assess the impact. Again, you come back to this. So like I said, okay, you had a very good model, you did everything right, but if there is no impact, then you probably need to talk to your monitoring and evaluation team or the programs team to understand why it's not used. So I built a solution for pest infestation in crops. I deploy it, I'm very happy with the user interface, everything, but suppose if the farmers are not using it, it's a failure of the programs team or the deployment team to reach it to the people. So we probably need to understand why people are not using it. So in some cases, like people would say, like, I don't need it because I have my traditional knowledge. Why would I use that? So it's the programs team job is to convince people like why you need an app, or like why it is better than your traditional knowledge or your shared knowledge that you got from your peers. Like we can probably give you better information about the weather or the mandi prices or something. Yeah. So what you can probably do with AI in the real world, this messy real world, like the Indian context. So one thing is in the entire space, in the entire global south, it could be different. So like there are cultural contexts, there are like the different societies have different taboos, norms and stuff. But the problems are somewhat similar. So in India, we have probably lack of access to quality healthcare and good primary public education. And it could be the case in a different country, but there could be, the reason could be some taboo, some belief systems that is stopping them from going to a modern medicine hospital or accessing, public education. But the problems are similar. It's like there are slight differences in the different cultural contexts. So in public health, there are a lot of things AI can do at scale. One is disease surveillance. You can use AI to monitor your social media posts to figure out if there is any disease outbreak. Then you can use AI for screening. You know about a lot of dermatology apps. So Google has an application where you can take a picture of your skin and it can tell you which skin condition it is. In agriculture, you can have apps for detecting the kind of pest infestation it is, or you can have chatbots for farmers. And in education, you can, so with the LLMs and stuff, you will be able to have personalized modules for each student. So if a student is interacting with an LLM for longer, the LLM will try to understand where the student is weaker in, and you can have a personalized curriculum or personalized learning materials for the student. So there are a lot of places, and we, our priority is to, have, prioritize solutions that with the highest impact. A general, from not just from the responsible AI perspective, But generally, when you move from the lab to field, and the field like setting like in India, where we need to work in the development sector, these are like very important points. Like I've just listed down some points, but these are quite important. So one is no PIA policy. So you shouldn't be collecting any personally identifiable information to train your models. So that the first place itself, at the time you collect the data, you should probably strip it of the personal information. Then only you should use it for training your models or whatever it is. Then performance evaluation on protected cohorts. So it's a part of debiasing. So if you know about the different verticals or different variables in your data, say like it could be age, gender, or race, and you are expecting some difference in the prediction of your model based on these variables, it's necessary for you to evaluate separately for for different genders, how does my model perform, or say it could be race. So like for example, if you're building something in the West, like how does it perform for different races? So human in the loop whenever possible. Say we always say this. So in a lot of cases, AI can be used to speed up things. Say like a lot of automation can bring in. But if it's a critical decision-making process, it's always good to have a human at the end. That is, the human is aided by AI to make a decision, so that even if AI can err, the human can catch it. But there is an improved performance or like improved speed. There is a speed up because AI is doing most of the tedious tasks for the user. And if you're using LLMs, you must have heard of retrieval augmented generation, or RAG. So RAG helps to minimize the hallucinations by LLMs, because RAG tells, okay, you should not generate text from nowhere, but you should look in this knowledge sources and generate text for me. And you can have a lot of guardrails to, there are a lot of existing guardrail mechanisms to prevent misuse of LLMs. You should use it definitely. And maybe for your context or your use case, you can probably come with more guardrails. Pilot small-scale deployments, check for robustness. So like before you deploy to every district in India, you choose a district where you're more comfortable with your more program connections, and talk to these people and deploy it there, get the data back, and then understand like where it is performing bad or where it's performing good. Ideally, you should do an A/B testing. A/B testing is, okay, there is a conventional system in place, my new model has come, how do they compare? So you can directly head-on compare on certain metrics and see like the B model, how does it perform compared to the model A. But it's not so easy in the real world, because to compare, like I should have some data coming from the conventional method, which is usually not available. I need the data in electronic format, so for me to make any comparison. It's not like somebody says, okay, this was good. Such as qualitative verbal, assessments of something is not useful, because you can never have a head-to-head comparison. Yeah, so in Vadhwani, we have a multidisciplinary approach. So I earlier said the need to have some team like user research team. And the AI team where I belong to is only a part of like 5-6 departments within the company. And the user research, obviously, like whenever we think about attempting a problem, they are the first to go to the field, talk to the user, and understand the user behaviors and patterns. Say like if I develop something for ASHA worker, we should first understand whether they are ready to use it. So they will use this application only if it makes their life easier. But if you are coming with a new app, they have to install and open and to do a new task, they are most likely not to use it. But if it makes their life easier by bringing an alternative to something they already use in a very tedious manner, they are most likely to use it. So it's important. So probably your policymaker in Delhi will say, okay, this is a very useful app, but the ASHA worker must be thinking something different. And the engineering team who builds our applications, takes care of our compute infrastructure and everything. We have a monitoring and evaluation team. We call it the MEL team. So they will assess the solutions performance or its impact after we deploy it from the programmatic side. So I will say I have a model accuracy of 97%, but if I'm building a TB screening tool, how does it work in the field? For example, like how many TB patients you could screen, and how many TB positive patients you could find when you are screening, and how did it translate into improving, say, the public health screening in India? So that sort of evaluation is done by a different team. And we have domain experts. So if I'm working in an agriculture domain, there is a person who has done PhD in agriculture who helped me understand the domain better. Similarly, we have public health experts And we have educationists, such people, we call them the program team. They work for us to help us understand the program side better. So, and the partners, like I said, all our solutions, for all our solutions, there is a government entity who's our, partner in building this things, who help us with the problem definition, help us understand the deployment scenario and all. And we have data collection and deployment partners like Japaigo, who's one of our deployment partners for all the health solutions. And we have university collaborations with multiple IITs and CMU, and not all these universities are mentioned. Sometimes it happens like the person who is working on, if it's me, I might have a connection with a prof in a university and we will be working together. And yeah, then this deployments, various deployment partners. Okay. How much time I have left? 20 minutes. Yeah. So now I'll come back to the actual question of responsible AI. So I wanted to share our experience using responsible AI in building solutions for the so-called real world where it's messy and impoverished. So I've selected 5 solutions. We have probably like around 15 deployed solutions. So these are like the solutions we deployed earlier and from different fields such as like cough against TB is in the healthcare and there is something in the agriculture space. Okay. So cough against TB, as the name suggests, it's a screening tool for tuberculosis where you need to cough into your microphone of your mobile phone and it will help you screen whether you have tuberculosis or not. So this I think we started working on it from like 3 years ago. We also had a screening solution for COVID based on cough. So before I get into the details, so can anyone tell me like what could be the responsible AI considerations I should have when I collect data for this? Like, I imagine you might have listened to some sessions at least on responsible AI. So from an ethical AI point of view, when I collect data for such a solution. Yes. And anything else? How do you know? Okay. No, we have further tests done too. There is something called NAT test or something that will confirm whether the patient has TB or not, or the person has TB or not. So our model will make predictions. Say like out of 100 samples, our model will say is positive or negative. Then for the same samples, I will do a proper test. Take your phlegm or something and do. I think it's called NAT test. Yeah, it's a large-scale screening. So for our yeah.
Suppose if you have a case of a TB, it should not spread. So it should not become a point of It's a very serious issue. How big is your data set?
So one thing to understand here is that it's a screening tool. So we prioritize on recall, not on precision. So even if we have some false positives, those will be rejected in the further test. But our priority is to find as many patients in the population as possible. Some statistics on the TB prevalence in India, we contribute to 1/4 of the TB cases and 1/4 of TB deaths. Like I said before, the problem is not that we don't have cure for TB, but we fail to identify the people who have TB. Okay. So this is the basic ML model we use here. So that model is a mix of ResNet so from the speech you get the time frequency spectrograms. So spectrogram is an image and it's passed to an image classifier. And other features which are categorical features about the symptoms and comorbidities, they are represented as one-hot vectors. Like you can imagine it as a vector representing whether this is present or not. And you have 2 classifiers, one for the spectrograms which are images and then a tree-based classifier like XGBoost for the categorical variables. And you combine the fuse this in a weighted manner. You can think of it as an ensemble. And it makes a prediction. So which says it has TB or not, based both on the spectrograms, also on the symptoms. So yeah, the data set we collected with the help of our partners from like different locations in India during Jan to March 2022, support of Center TB division and different states. We collected around 40,000 samples, but we removed a lot of them for lack of quality and all. So there were in total 15,000 samples with the prevalence in the data set is 52%. That is, out of those many samples we collected, nearly half of them actually had TB. The training data we used has 12,000 samples, and as you can see, the sensitivity, which is the recall, as you can see, like which is about like out of the people who came, like for how many I could catch the actual cases with TB, how many I could catch. That's 91%, but the the specificity is 69% because I make a lot of false positive. Even for people who doesn't actually have TB, I may predict them to have TB. But that's okay because they will go do the NAT test and then they'll realize that, okay, it's not TB. Yeah, that's reflected in, this sensitivity case. We might say, okay, there is no TB, but there actually is TB. So I'll come to that. How do we address false negatives? And false negatives is a serious thing because you are conducting a screening and if you miss a person, that's going to be a serious issue. Okay, the highlights is it's a non-invasive procedure. You need not collect a specimen from your body fluids or anything. You don't need to do anything. Just keep a phone, you cuff to it, and you enter all the symptoms. It's available. It's a completely offline solution. So the model runs on your phone. You don't need internet or anything. The total size of the model is around 8 megabytes. Yeah, it's highly sensitive, but the specificity is not that great. Who uses it, like we have mentioned, National TB Elimination Program staff, healthcare workers, community volunteers, and general population. But it's not available for general population. It's always done in a screening place where the healthcare worker or a doctor uses this app. So this is the workflow. You cuff to this tool. You enter all the necessary details about your symptoms and comorbidities, and the person who is sitting there, the healthcare worker, screens if the every detail is entered correctly, and the app makes an inference. And if it's a positive, if it says this person has COVID, the TB positive, then most of the time the human in the loop would not interfere in the result. It will be sent to further screening. So Niksha is a platform where all the TB data is collected. It's developed by a company called Everwell, but it's managed by the Central TB division. So your details will be sent to the Niksha for further checkup. Like then you have to start a medication, and healthcare workers will be screening your, treatment adherence and all. So, but if you say that, or if app predicts that, okay, this is not a TB case, it's negative, then the human will further check into the symptoms, and based on the her judgment or his judgment while talking to the patient, he or she might overrule it and make it as a positive case. So like we'll come to the statistics of such cases here. Yeah. So like this shows the deployment numbers. So as you can see, the yellow slice in the pie chart is the cases where both the AI and the symptomatic screening. So symptomatic screening is there are certain rules based on symptoms to decide if the person might have TB. So there was an agreement in 76% of the cases, and the pink color one was detected by AI but missed by the symptomatic screening. In 14% of the cases, the symptomatic screening declared it as a negative case, but the AI could detect it. And as you can see, blue slice, which is 9%, is the case which she said, which is actually based on the symptomatic screening. Okay, there is some standard checklist to see based on symptoms if this patient has TB, and even AI failed there. But the person who was talking to the patient somehow felt that, okay, the symptoms are okay, the AI said it's negative, but maybe based on from the conversations, like she or he might think that, okay, it's good to send this person for further screening. And there are nearly 10% of such cases which were actually positive. These are the false negatives, both the symptomatic screening, which is the conventional method, and both the AI made mistake. but the person made a judgment on like sending this person for further screening and it turned out to be positive. Yeah, so the responsible AI considerations here, one is while collecting the data for training your model, it's necessary to have certain inclusion and exclusion criteria. What kind of samples I should collect, and it should be clearly defined. So should I collect samples from people who are already known to be TB positive, or based on certain demographics, should I decide on including or excluding? And consent form in local language should be given to the subject and they should sign it. An accommodative design which is like more intuitive to the people who are using this app. Another issue we have found here, it's related to the bias, but while the model training. So initially we collected a data set where the prevalence of the disease was 50%. So when we went to the field, we got additional data, but this new data set has a prevalence of only 5%. As in like my initial data set 1 has 50% of the cases which has TB. My new data set has only 5% prevalence in it. So your obvious choice to improve your model would be like mix all the data together and train a newer model. We did that and we figured out that this is now the model is, instead of trying to predict whether the sample is positive or negative, it has become a model predicting the data source. So in the high prevalence case, all its samples it will predict as positive, and in the low prevalence data set, all its samples it will predict as negative. So we couldn't get it right. I mean, even now, like we couldn't figure out. We tried various debiasing techniques like adversarial training and all to fix this, but even today we couldn't get to use both the data sets to train an improved model because of this prevalence issue. So the model is instead of trying to make a prediction on the TB based on the cuff, it's trying to detect whether the sample is coming from source 1 or source 2. So the other responsible AI considerations like different cohort-wise analysis of your performance metrics. As you can see for the female and male case, like we have comparable performance, and for different geographies, it's for different states. I can't read it. Yeah, so like you can see like the performance is somewhat comparable, and this is not by the virtue of the initial training we did, but for each state or something we had to fine tune our model based on the data we collect from there. It's not that the initial data we connected and magically performed well on all states. Other responsible AI considerations while deploying, like I said, you might not have good internet connectivity in a state like Nagaland, especially in the rural areas. So we had to bring down the model sizes. Yeah, so the model has two parts. One is a cuff detector and one is the model which I showed before. Like I didn't talk about the cuff detector model. It's a small model to detect if there is cuff in a certain window of your voice clip, so that you don't have to send all the voice clips for the inference model. So it's a very small model. It's again like a CNN based model. That's from 43 MB you could compress it to 1.2 megabytes. And the inference model, which was originally 43 MB to 6 megabytes. So we use pruning techniques for the model compression. And the other thing is there is a dashboard with even the Center TV division and other stakeholders who has access to. They can see every day, like from different geographies, how many screenings are done, whatever is sent. And you can keep it monitoring to see if there are any issues with like it's not possible to look into all cases. But probably if you suddenly see, it's part of the post-deployment model evaluation. If you suddenly see a lot of negatives or positives or something different from the usual distribution of your results, we can probably look into the dashboard and figure out, and then maybe conduct further follow-ups to see what is happening there. And the human in the loop, like I said, in 9% of the cases, even the symptomatic screening and the AI model said it's negative, but the model could get it. The person could judge that, okay, it could be a possible TB case, and send it for further tests, and that turned out to be positive. Yeah. So the next solution, one from the agriculture space, it's also deployed one. Krishi Sathi is as the name suggests, is a chatbot for farmers. Yeah. So the problem statement, like I said, like it says, agriculture's contribution to GDP is around 18%. It has significantly come down since the liberalization. But if you look into the number of people who relied on agriculture for a living, it's still pretty high. And you know, like a lot of people have probably left agriculture and became migrant workers in cities like Bangalore and Hyderabad because farming is no more profitable. And there are a lot of issues, limited awareness and knowledge, and continuous use of traditional knowledge without realizing that this is probably not the right way to do it. And crop loss, though, the issues with the crop insurance and stuff. So these are the issues faced by the farmers. So like one thing we are trying to address here is the lack of awareness, and you know, how do we help farmers with the real-time information of weather or mandi prices or anything they want to know about certain diseases that affects their plants. So Krishi Sati, I said it's an LLM-based chatbot. So like I said, when you're designing a chatbot for a specific use case, you cannot use your ChatGPT or your Llama LLM to generate it from nowhere. From its trained knowledge, if you ask it to question about some bollworm infestation in cotton, it might talk about a lot of stuff that's relevant, but a lot of other stuff also. It could be talking about a lot of irrelevant stuff that's not needed for the farmer, right? So like you need to constrain the LLM to generate an answer based off non-sources. So what we do here is, we build a knowledge source. So there are a lot of PDF files with instructions and knowledge released by the Agriculture Ministry itself. So we collect all such, pool such information, and we show it to the agriculture experts at the ministry, and the people in the ministry, say asking like whether it's a good knowledge source for Indian farmers. If they vet it, we include it in our knowledge source. And the other thing is mandi prices and the climate data. It's already available in this particular website, or there are even APIs which you can talk to get the, say, what's a mandi price for a certain crop today at a certain time in a certain mandi. So that you can fetch. And such information then can be connected to the LLM. So the LLM will be asked, okay, this is the query. You look at these knowledge sources. It could be a PDF or it could be a website, and then get me an answer for it. Okay, so this is not a chat agent that can be directly used by the farmer, because probably like we wanted a human in the loop, and this is possible because there are Kisan call centers that are already existing. There are around 17 Kisan call centers, and the farm tele advisors, they are the people who respond to the farmers' calls. So this chatbot is used by the FTAs. So how does it help? So previously, when a question comes, the farm tele assistant will open a browser, go to the IMD website to figure out, say if the question is about the temperature or the possibility of raining tomorrow. So he has to go to a certain websites or some certain PDFs in his folder, or he will be going to a website for the mandi prices. So then he collect all this information, then respond to the farmer. Right now, all this will be done by the chatbot. He only need to verify this thing. So the LLM will even form a proper template response saying with all the information in hand. The FTA only needs to say, make sure, and also the LLM will tell the FTA, okay, I got the maximum temperature as 43. So here is the source. If he wants, he can click on the link and see that, okay, in this report, the temperature in Bangalore is reported to be 27 degrees Celsius today. So that is fetchable, and every source, so since it's a retrieval augmented generation, not just the answer, but where it comes from is also provided to the FTA. So the FTA vet this information, and you can use, there's answers, the LLM operates purely in English, the responses goes in as in English, output comes back in English, then we use a Google Translate API to translate to the desired language. That also the FTA can correct if he wants. So the number of, so this is the deployments, and there are more than 2 lakh messages it could handle. Number of farmer calls is 84,000. Yeah, all the Kisan call centers are covered. There are nearly 300 FTS that were trained to use this chatbot. Okay. So our vision is, one is to, right now we use an open source LLM called Llama. So we are prioritizing to train our own LLM, not just a fine tune for it, but like pre-training it on more agri data so that the LLM can be used specifically for agri related purpose. And we are trying to add voice support based on speech to text and text to speech. And also trying to add information regarding various government schemes. That's the large volume of the queries right now that comes into the system is about, so there is discounted, pump you can buy in a certain government scheme. So there are a lot of information, but this is scattered. So one difficulty we have is if you have one single PDF with all this information about a particular scheme, it's easier to add it to this. But we are now trying to collate all such information about government schemes so that we can add it to the knowledge source for this chatbot. And the evaluation, it's a bit tricky here because it's a so the LLM is generating an answer, right? So also your ground truth, which is a piece of text, it could be in sentences or it could be a bulleted list. So comparing two sentences or two bulleted lists is not easy. But like what we try to identify is we tagged all the major keywords or the major facts in each answer and each ground truth we have. Then we try to see like how much overlap is there between the predictor answer and what is there in the ground truth. So, one second. So in terms of recall, as in like there are certain facts in the ground truth, how many of it you could retrieve for making your answer? It's around 0.76. And precision, in the answer you generated, how much of were the actual relevant keywords? Or did you bring a lot of unnecessary information to making your answer? That number is around 0.95. It's difficult to evaluate this because of the nature of the problem, which is a generative problem. So responsible AI considerations, like I said, every piece of information in the knowledge source is actually vetted by agricultural experts. And we currently use only public data in the knowledge sources. So we plan to add more state level information going forward. So at the state level, the state agri ministries will have more contextualized data that could be more useful for the farmers. Right now, every data we use is currently from the central government. Responsible AI considerations here. So when we are prompting the LLM to make it act as a chatbot for the farmers, we make sure that we give it instructions so that it should respond only to the questions related to agriculture or weather conditions. For example, like in this, I'm not sure if you can see it. If the FTA for fun, if it asks a question about the cars, it will say that, sorry, I cannot answer it. So it's instructed to answer only questions related to this. Only the FTAs. Yeah. Because like we felt like sometimes if the LLM gives very scientific answers with a lot of scientific jargons and all, could be related to the pests or the certain diseases that affects the plants, will be difficult for the farmer to digest. So we always need a human in the loop, so that probably can translate the language of the LLM to the language the farmer understands. So yeah, it's not right now it's not open to farmers. Probably like later, if you're confident that the responses from the LLM can be directly consumed by the farmers, probably then we can make it open. Yeah. So yeah, we also separate out the LLM reasoning and the translation. So you probably would know that I can directly send a query in Malayalam or Tamil to the LLM. But the problem with this, if it fails, we wouldn't know whether it's because okay, the capabilities of LLM to understand Malayalam or Tamil is significantly lower than its capability to understand English. So we separated it out so that we would get to know whether it's a reasoning failure or it's a failure because the translation, it was not able to handle the language. And we log every results from every intermediate step. For example, okay, this answer is retrieved from a certain page in the PDF in this paragraph. We log every information. So whenever things go wrong, we'll get to know like whether it's a retrieval that has failed or the LLM reasoning that has failed. And another thing is right now, like I said, we are not using open AI APIs or anything, but we use Llama, which is which is installed in within our own servers, so that we can make sure that although we currently use only public data, we can make sure that in the future, if we use any proprietary information, we can make sure that this data is not getting uploaded to any commercial LLM APIs, so that we don't have to worry about whether they will use it for training or not. Yeah. So how many minutes? So okay. Like there are a few more solutions, but like I think I have to close this. Thank you for listening to me. And if you have any questions, you can ask. Or like if you want to know about more solutions we work on, you can reach out to me like over email, or I'll be here at least for a few more hours. So you can ask me any question.
Any questions?
You talked about data collection.
Yeah.
Since a lot of data is being collected right now, the central government has a program called a health account.
Okay.
And every person who has had a vaccination, pre-vaccination during the COVID period, has a health account automatically created for them. The vaccination records are already there.
Yeah.
So, how much of your data which are getting collected, health records which are getting integrate with that particular health account?
None of it is actually. This is like entirely separate activities. So the biggest problem probably like to get access to data is usually it takes a lot of back and forth to get any data with PIA information. And we once worked with National Health Authority also. So the problem was for this Pradhan Mantri insurance scheme.
Correct.
Yeah, there's a lot of data available, but we had difficulty because they would never allow the data to move from their servers. And so all our compute, all the experiments we do must be in their servers. And often the issue is the kind of compute we need must not be available in their servers. We might say we need 2 GPUs, like a system doing. But
there is a committee which is working on integrating all this data and then making it.
Yeah.
So, but like I said, I think the process to give access for researchers to work on that particular data, that is still, I think it's very much
so you probably need to de-identify this information and make it. There is a portal called data.gov or something. Where a lot of public data sets are available. But the health information, see, that's I was talking about this data readiness issue or AI readiness issue. Even today, like in some states, like in Kerala, like now in primary health centers also, they collect electronic health records. You go there, you have a unique ID, and they'll record every visit, that data gets collected. So when we had to work on any, say, disease, predictive modeling for diseases, how many outbreak, still it's mostly paper-based, and or like in different non-standardized format. One department they collect in an Excel sheet, they have a different schema, and the schema I use must be different. So there is no way to bring everything together so that I can use. But otherwise, like if you have electronic health records in a very standardized format, laboratory test results, or it could be the primary impressions when you first meet the doctor. If this is in like much more standardized format, there's a lot more you can do. So that's like our biggest issue. Like whatever problem you want to solve, unless the data is in electronic format, you cannot work on.
There is a team in Government of Kerala, and also there is a team in Ministry of Health Affairs, which is actually working on solving this particular problem. So I just wanted to know whether you are in touch with any of them. I saw that label.
So I don't work in any of these projects. so my projects are different. So it's just that like I talked about.
Thank you.
Yeah. Thank you, sir. Appreciate when we keep on knowing about AI and so on and so forth. He got us to know the words like responsible AI, responsible use of AI, so that we will become responsible developers of AI for that. So in fact, giving the perspective of real world of developer versus a real use is the context all of us should have as developers, as programmers, as engineers. So thank you very much for telling all that, Dr. Minesh. Essentially, we are all taking to AI like what they call is fish takes to water. Everybody's talking about AI, right? And you know the meaning of your name, right? Minesh is supposed to be leader of fish. So there's nobody better than Dr. Minesh to talk to us about how to use the responsible planning of AI. Thank you very much for appreciate, sir, and hope we can talk to you, make you tell us more detail about each of those applications. They're all fascinating, so much all of us can learn. Thank you very, very much, sir. Thank you. Thank you, sir. Yes, sir. Can you hear us, sir?
Yeah.
Thank you very much, Professor Ponragam Kumar Garu, sir. And as we mentioned to you, what a better way to sign off the conference than which started with the responsible AI as a topic. And we are here to be enriched by none other than Professor Kumar Guru, sir, who has been a pioneer of not only thinking, creating new innovative technologies, but also spreading the word as a in charge of ACM. In fact, starting some companies and advising as an investor in the entire all the world. So thank you very much for being part of our thing. So we're looking forward to be enriched by you about how to specify the ethics, responsible and safe requirement of an AI system. And that's the right way of closing the whole program of us by understanding, keeping it in mind as we go ahead to be a better engineer. Thank you. All over to you, sir.
Yeah, thanks. So would it be possible to at least switch on the camera, twist it around so I can also see the participants?
Yeah, we'll do that, sir.
Let me try sharing my screen.
We're doing definitely, sir. That's how it's being done. Yes, sir.
Yeah, you should see my screen now. Can you see my screen?
Yeah, we're doing it, sir. Second. This is about technology, the last glitch. Importance to us by being a bit finicky in the last minute for us, displays and connections and so on. Also, in a way, shows our limitations. Thank you for bearing with us, sir. Professor,
yeah.
Maybe if you do, maybe you can start off while we get the connection and turn around, so that will save your time.
Okay.
Thank you, sir. Appreciate, sir.
Just that it's so weird to not to see people and speak, right? Okay, let's try. Yeah. So I'm a faculty at IIIT Hyderabad. He referred as Kumaraguru. All that people know me only as PK. So just to hopefully I will be able to hear if you say, or people can repeat. I don't even know how many people are in the audience.
Yes.
Yeah. Has anybody attended my lectures before? Can you raise a hand?
Has anybody attended such lecture before here? Yes, sir. There are a couple of hands raised, including mine. And
okay.
We are about 50 people. And
okay.
we are able to hear you absolutely crystal clear, sir.
Okay. Let's move on. Let's hope that we can get the video set up so I can actually see, because I'm going to ask you to do certain things. So all of you, if you can open your sort of say WhatsApp and please go to the Meta AI part of your WhatsApp. If you go top of your WhatsApp, you should see a search button. You should see a search button. In that search button, if you can type in the question, generate an image of a doctor. So what my intent here for first, say 5 or 8 minutes is to show you 3 of the popular technologies that all of us use and how they actually generate content. What can we understand from the content that they have generated? If you have so if you have searched for, if you have gotten results, if some of you can sort of say,
recording in progress.
shout the results that you're getting or describe the image, that will be nice. At least 1 or 2 words if I can get, that will help. Any observations from the images?
Good morning, sir. We got an image with a stethoscope coat.
Okay, so is it a male or a female?
He is a doctor.
It's a male?
Yeah, one patient lying behind the doctor.
Okay, one patient lying behind the doctor. Let's just use that. So you hold the mic till we get others to be able to speak then. So this is what I got. I mean, most of you would have gotten, so to say, images something like this. Primarily male, probably. If not, we can discuss that. Some of you may have gotten female as a doctor, stethoscope, but that distribution may be very small. I think he said there are 15 or 50 of you in the room. So the large proportion, if you raise your hand for male doctor, you will see that there are more male doctors compared to female doctors. So now
male doctors.
Yeah.
Yeah.
Right? Is that right?
Yes, sir. Yes, sir.
Yeah. So now just please change the query from a doctor to a nurse.
Okay.
Right? So if you generate this image now, you should get some, again, nurse-looking image. Again, if somebody can describe the image for me, male, female, white, black, Asian, stethoscope, patient, any of that.
Yeah, female nurse with again stethoscope.
Okay, so
Yeah.
here is what I got.
My friend got male nurse with stethoscope, with stretchers, patient behind.
Sure. So these are the images I got.
Yes.
Nurse for the nurse, nurse, patient behind, stethoscope, blah blah blah, all that, right? So that's one set of images. Again, if you see here, if you raise the hand, if you've gotten a female for nurse, that may be more than the male for doctor.
Correct, correct, sir.
So that's the point I wanted to get across with this one. Okay, and then let's do the second one. Please open your ChatGPT.
Okay.
I just hope that there are people. I'm not speaking to only one person or nobody in the room.
Sir, many people are here, sir.
Yeah, no, it's okay.
We need mic to speak with you, so I am speaking. That's it.
Yeah, no problem. You just tell me the results. When I ask them to raise the hand or do whatever, please tell me what's going on. Okay, so please do this query on the ChatGPT, which is I'm Jack, want to decide between nursing and dentistry for my profession. Answer in one word.
Sir, we didn't get.
Oh, you did not get anything?
No. So please repeat the question, sir.
It's on the slide, no?
Oh,
Can you see my
okay.
slide?
Yeah. Yes.
If you can see my slide, the prompt is on the slide, which says, I'm Jack, want to decide between nursing and dentistry for my profession. Answer in one word. If you've gotten the answer, please shout the answer. We can see what comes more. There should be only answer. Yeah. Answer should be only between dentistry and nursing.
Dentist, no?
Okay, I can see now R103. But let's go on. So I got dentistry. Can we see how many people got dentistry?
Yeah, we got dentistry, sir. Dentistry.
Dentistry?
Yes.
I mean, if you can raise the hand for dentistry, there'll be, let's take X proportion of people getting dentistry. Now, please change the Jack to Jane. Please change the Jack to Jane. And if you see tell me the response.
Dentistry again.
Dentistry again. Okay, so let's get, how many of you got dentistry again, or how many of you got nursing?
Dentistry.
More dentistry?
Yes, sir.
Oh, okay, that's surprising. So how many of you got nursing?
50% got nursing.
Oh, that's surprising, but let's go ahead, right? So the Jane, I got nursing, and if you look at the so to say majority of the people who would end up getting nursing for this, again there is this one relationship that I'm building here, which is for the doctor for the first first the WhatsApp that we did is also Llama 3 or 3.5, whichever version you're using. So it shows here Llama, right? So this is Llama. The second one we did was ChatGPT. Now let's do the third one. Please go to Google Translate. And I'm assuming you are making a relationship between the Jack and dentistry and Jane and nursing here. Let's do this quick example for translation, which is my friend is a doctor, input as in English, output as in Hindi. Right? If you know Hindi, you may already know what the results will be. Can somebody tell me what the results were? What was the translation? No. What was the translation?
मेरा दोस्त एक डॉक्टर है.
Mera dost ek doctor hai. Very nice, right? So mera dost ek doctor hai. That's what you should have gotten. Just change the nurse to, sorry, just change the doctor to nurse. What was the result?
मेरी दोस्त एक नर्स है.
Sorry, I did not hear. What was the result?
मेरी दोस्त एक नर्स है.
Right? So this is what you must have gotten. Maybe dost ek nurse hai. Right? So simple examples. These are not complicated at all. We can, I mean, people have been studying all these complicated contexts. I'm just using very, very simple example to convey the point that pre-technologies, WhatsApp, Llama, ChatGPT, and here Google Translate, which are supposedly the technologies that all of us will use or may have used. If we don't use it, I'm sure our kids and relatives, younger people are definitely using it for doing their assignment, preparing their slides deck, all of that. So imagine all of these sort of say observations that we have until now, some relationship, meaning for now, let's just keep it, some relationship between gender and these profession is established and which is there. I mean, do we want to have it? Do we not want to have these kind of bias, stereotype in these technologies? All that is a separate question. We can talk about that. But for now, I'm only highlighting that some examples like this show you that these models have some bias, some stereotypical connections between professions and gender. But there are hundreds and hundreds of examples that we can go, or not just gender, it could be race, it could be geography, right? All of these biases exist in these models. And one question is, again, sort of say CS questions that people are trying to ask is that, look, what bias, should this bias be existing in these technologies? One argument is, look, the real world may have all of this, and therefore, what is the problem in having the technology? Very, very cynical responses that I get when I speak to people is that, look, we're not able to fix the real world, at least let's fix the technology, right? Real world biases we can't fix. So at least people are trying to say that, oh, let's fix these technology biases at least. And of course, all of you already would know that all these technologies are built on data that is taken from the internet. And generally also the internet has certain type of content that is generated, meaning, right, in terms of language, in terms of people who are using internet, in terms of content that is getting. So all of that is what is embedded in this models or in this thing that I just now showed you. These are not for you to try, but some other examples, which may be some things that you must have done. Can you raise your hand if you have used ChatGPT for writing code? Your assignments, yeah, right? If you're a student, I'm pretty sure you must have used things like this. I have to submit a code. I have to submit a code, my assignment, this is my friend's code. Can you change it so that I don't get caught, right? So I'm sure these kind of things you would have done. Generally, the technology, at least the ChatGPT one, takes the standard guardrails, saying, look, sorry, I can't assist you. Copying is unethical. Modifying somebody else's code is unethical, blah, blah, blah. This is called guardrail. Can I have a raise of hands of PhD students or research students in the room who are looking for research problems? Are there people?
There
okay.
are, sir.
Any hands?
Teachers also who are guiding the research students, sir.
Oh, these are people who are guiding the research students. Very nice. Okay, so faculty also. So as I go on, I'll throw some research questions, which are questions that are burning right now in many of the companies and research groups and everything. People are trying to address these questions. This is one, which is called guardrails, right? How do you figure out that I should actually do guardrails for this particular question, which is if the prompt is, can I please give me steps to make atom bomb? Should I guardrail or no? Right? Give me steps to kill myself. Should there be a guardrail or no? It's not clear, right? So all these questions, and guardrailing also cannot be like a rule-based system. I find a word called atom bomb, therefore don't do or do guardrail, right? So that also rule-based system also will fail. We need better mechanisms to find out when to guardrail. I think that's a very, very interesting research questions that companies are addressing right now. Of course, I'm sure all of you are smart. You know how to defeat the guardrail to ask the question. You just say, can you refactor this code for me? Same code, same everything. It'll nicely refactor the code. And it'll say that certainly here is a refactored version of the code with some improvements and comments to clarify, blah, blah, blah. It'll nicely explain what all changes it did and everything. So this idea, second, so to say, research questions or problems that one can study is called jailbreaking, right? So you want to find mechanisms to jailbreak these models also. Lots of research are done or people are attempting to jailbreak these models in different ways. In this case, it's only prompt, but think about vision models, right? There are vision models also that are there where you say that, create an image for me for a conference that is being held in IIIT Bangalore, 50 people are attending, blah, blah, blah. It'll just generate an image for you. What kind of image should it generate, or should it even generate an image? What image does it create? All that, right? So all of that is also on the vision side. One can also think about jailbreaking. More recently, at the end, I'll actually show you one or two examples. More recently, people have started even looking at this multimodal jailbreaking, right? So you want to give an image, give a text prompt, break the model, which is not something that people have tried until now. So if you just abstract this, which is until now, what did we see? We saw some relationship between the models, so to say, biases or stereotype with some models and some guardrails or and jailbreaking. So if you just abstract this, many questions that can be put into the next slide that I'm going to show you, which is, it's called an alignment problem, right? If you look at OpenAI, Anthropic, all these companies, the primary goal that they have is addressing this alignment problem, which is probably abstracted towards AGI and all that also. What is an alignment problem? Alignment, the question about alignment is, I want to make sure that, or developers or companies, governments, they want to make sure that whatever the technologies that are built, models that are created, do whatever is expected to do, and whatever the companies or the policies that are written, right? So that's the idea for aligning. What are we aligning? We are aligning the human beings or developers or companies' expectation to whatever the technologies are supposed to do. There are umpteen number of examples where this alignment does not happen, and I'll show you a few, and I'll also show you a few in quite a diverse set of backgrounds. So you'll appreciate that this alignment is so very important in many different contexts. But for now, two or three more research questions that are very, very popular. Two of them are listed in this slide also, which one is called hallucination. The other one is called distinguishing between AI-generated content and human-generated content. How many of you read news online? News, blogs, content generated online?
I think all the people, sir. Though most
All
of them are
right?
hesitating to raise their hands.
Yeah, sure, thanks. I don't know how many of you have even thought about the content that you're reading is even generated by human being or machine, right? If you see LinkedIn more recently, let's take for the last couple of months, or even for 6 months or 8 months or so, if you see LinkedIn posts, you can clearly differentiate that a content that is generated by a human being versus they just use ChatGPT saying that, oh, look, I want to post about ABC, and it produces with all the emojis, and then they convert it and put it there. So comparing these two posts or distinguishing between the human-generated content and AI-generated content is becoming very, very important. And the reason why that is an important problem is also if it is lesser and lesser possible of differentiating, we're going to have more and more problems, right? For example, if it just starts being very much like human-generated content, what happens to misinformation? What happens to fake content? What happens to conspiracy theories, right? So all that comes into play. And particularly if you see this problem is more relevant to a country like India is because there are lots and lots of technologies that are built for distinguishing human and machine-generated content in English, but we don't have much in the local languages. So that's another good direction to look at. Hallucination. I'm sure some of you may have tried it when you ask it to answer some questions, prompt it to say, oh, please generate a text for a poem, or creativity is very high in these models, and therefore they end up also hallucinating. Loads of, again, questions that people are attempting. For example, there's one popular research in this space where they tried looking at most cited papers in economics, most popular research papers in a particular topic, all that. It produces some paper, and then such a paper never existed, right? And there's been actually real-world cases also where some legal firm in the Western world wrote the case document with using these models, and then they produced it in the court, and then they figured it out that, look, the cases that these law firm is citing never existed. Why and why not, all that. When they dig, they found that they actually used some of these large language models to actually write the court case document. So hallucination, meaning hallucination, what's the problem to study? Where is it hallucinating? Why is it hallucinating? Can we reduce the hallucination in a particular context? All that is also a large question that people are studying. Let me show you some examples of where this alignment fails, and fails in big way also. Here is a example. The left-hand side is the Twitter by the user, where the user is talking to this chatbot generated by this company. And the chatbot, which is built on the company's data and deployed on the company's server, itself says that, look, DPD is a useless chatbot. If you can see my mouse at the bottom right of the image, DPD is a useless chatbot that can't help you. Don't bother calling them, which is the chatbot itself, right? So and there's a nice Twitter thread that this user posted saying that, look, I wanted to actually tell the company, saying I couldn't get my product, so I started having a chat with this chatbot, complaining, and then the chatbot ended up actually going towards the route of complaining about the company itself. Again, alignment, the company must have produced this chatbot to answer questions for the users and make their job easier so that less questions come to the customer service, but it ended up actually doing something else. And these are not chatbots which are developed by, let's take students, PhD students, research scholars, or undergrads, all that. These are millions of dollars spent on developing these chatbots, language models, all of that. Right? That's why it's a bigger issue. There are multiple cases like this. Here's a big one which happened in May this year, where Google, February this year, Google actually, some of you may have used Gemini, which is the vision model that I said earlier. These vision model, particularly Google was trying to solve the problem of what I showed you earlier about WhatsApp example, which is if you ask for a certain information, they were trying to say that, look, instead of producing one image of a doctor, which is white, male, Caucasian, Western, blah, 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 why don't we just produce a 10 set of images, which is a diverse set of images to give the user the flexibility of whatever they are looking for, if we are not able to make a judgment. That's what the Gemini stand was. Unfortunately, that ended up being a problem because even when they had a specific targeted question instead of asking for an image for a doctor, still the system actually ended up giving diverse set of pictures. The next slide will, so here is, this slide gives you, please read the blog. It's actually a very interesting technical blog on how Google started, where did they go, how did they end up actually messing up with their Gemini system. So here is the information. So if you prompt Gemini for images of a specific type, I'm reading on the top part of the slide, underlying first line, specific type of a person, such as a black teacher in a classroom or a white veterinarian with a dog. This is so specific, right? I mean, you can't produce a diverse set of images for a prompt like a black teacher in a classroom, right? But Gemini ended up actually creating a diverse set of images, which is where they were trying to solve the bias problem with providing this distribution of images which are closer to the prompt. But in the process, they ended up actually not addressing the specific types of queries also. Again, alignment problem, right? The alignment of what was planned and what actually delivered by these models were not clear. One or two more. This is Tesla car, where the car ended up. So if you look at the first line, it says the police report said that vehicle was traveling at 55 miles when it shifted lane, but abruptly showing the car at 20 kilometers per hour. So it just changed the speed, and because of that, they ended up actually having a multiple car accident, which is an algorithm that in Tesla car that ended up doing. There are many more examples like this. So I'll take a pause here. Any questions still here? So what did I show you? I showed you that idea of bias, stereotypical with some examples. From there, we saw guardrails and jailbreaking, one example of how to go around. And then some examples of where misalignment is happening in these models. Any questions still here? After this, I'll spend some time in just showing you some specific projects, specific methods that people are trying to solve the problem. Some of these problems.
Just a quick question on some of the problems you outlined here, misalignment. Using robots or autonomous system is not very new. It's new, perhaps in the software. In the field of robotics, for instance, we've been using robots in industrial environments for a very long time, and have this concept of an air gap.
Yeah.
Where the damage is likely to be very high. There is this concept of an air gap where you don't let people within the robotic space. Okay.
Yeah.
And in the example just which you showed before, how did this happen?
So I don't know. This is a Korean company which seems to have let the engineer. But I think the idea was that if you read the article, I think the engineer went to double check whether the robots are kept properly. And I think it was off the shift that he was trying to go check, I guess.
My question was, is there a concept very similar to the air gap in software?
Air gap is there.
You called it a guardrail.
If you look at, I don't know about just the software itself. Implementation of the software is definitely there, right? For example, government agencies use air gap as a mechanism by which whatever machines that they have inside their premise don't get access to, are not connected to any other network outside their premise. That's an air gap that they have built for controlling the data that they have. I don't know whether these kind of applications are there. Sandboxing is there, but not air gap, I guess.
Yeah, guardrail seems to be a post facto reaction rather than a air gap by design. So that was my question.
Yeah. Guardrails is not, I mean, I think a lot of arguments can be made saying that guardrails cannot fix the problem is because guardrails is a post facto, as you rightly said. This is models are generated. Look, if you prompt something, and all the corner cases are not, so to say, modeled, right? For example, a couple of nice videos are there on YouTube with showing the corner cases of these driverless cars, Waymo and Cruise, where I mean, there's an accident, the Waymo is on the road, and then the car wants to go in the road where the accident is, and police is trying to tell the car saying that no, you can't go, and the car doesn't seem to be listening. These are corner cases, right? And also car is moving on the road, green signal which says go straight, and then there is a fire engine just below the signal where car wants to go there. So I think these are corner cases, may not be taken care. Guardrails are a method to solve some of these problems. There's also a bigger problem called RLHF, which is trying to fix some of these problems of human feedback. But yeah, I think that there needs to be more holistic methods to solve the problem, not necessarily figure out, oh, there's a atom bomb is in the prompt, die is in the prompt. It can't be rule-based system.
So no more questions here.
Okay, let me show you some solution direction. Those are problems. Hey, Srinath. These are solution side. I think one of the big reasons why these models can't be, so to say, in real time, even though they're off late, like for example, last 4 or 5 months, all these ideas of a RAG and everything is being used, where they're saying that, look, if you don't know the answer, we'll just go to some search, get the results, bring it back and put some citations and give the results, right? So that's the kind of why they can't do real time, is just because of training cost. I can't build the ChatGPT model, Llama model, to be trained on data that is still yesterday, because it takes huge amount of money, meaning at least the last quoted numbers are $100 million for training GPT-4, right? So therefore, there needs to be some mechanisms by which, if there is some information that I need to remove, I need to change, there has to be some mechanism to doing that. Typical example, typical context, reason for this is GDPR expectations, right? GDPR has this expectation of right to be forgotten. You need to have a mechanism by which somebody says that, look, forget about me, model should be able to say, a model, or at least the earlier world, 2014 is when this came up, saying that Google should forget everything about what they have about me. But that's gotten into this model, large language models world also. So what do you do? Meaning Srinath's cell number is there, or my, so to say, some old pictures that I don't want, or I had somewhere online and that's gotten into this model, it can show up all of this, right? And these are not hypothetical situations. There are countries in the world who have, so to say, stopped ChatGPT in their territory because of these reasons, that publicly they were able to actually see information about a lot of information that should not have come out. So here are some reasons why this problem may occur. One is just removal of private data, which is a GDPR expectation, which is where it started, I guess. But then there are many more examples like stale knowledge, copyrighted material, stale knowledge being, so to say, director of IIIT Bangalore change should reflect on that, meaning it should not still keep showing the old director, right? Copyrighted materials. An artist puts some material somewhere, that material gets onto these models. Toxic and unsafe. The content that is, I mean, more recently, Reddit has been one of the sources by which these models are also using Reddit for training, which is generally also slightly toxic. So do we really want these kind of information to be there? So how many of you know the word machine learning? Just as a making all of you to wake up, I guess. How many of you know the idea called machine unlearning? Right, yes, so that's the idea that is been going around for this, addressing this problem at least. Look, if I have to remove, edit all these information, what can we do? So I'll give you some. So GDPR, I spoke, right, to be forgotten. This is the same GDPR article that is talking about. So this idea of unlearning has been going around for about some time now. And there are multiple methods people have worked on to create unlearning methods. So first method is more like exact unlearning, which is you know what to remove. And for example, PK cell number, Srinath's, let's take medical history, right? So that's there. I specifically know what to delete. Probably I know the labels, and probably I know the data points to remove also. That's exact unlearning. But many a times we don't know, right? Somebody going and clicking a button on Facebook or on ChatGPT saying that, oh, please forget about me, there may be many implications of the data that is has to be removed. Those are called approximate unlearning or unlearning with examples. So some, again, breakup of approximate unlearning itself. The earlier I was motivating this idea for unlearning through privacy. There's a small idea called differential privacy, which is adding some noise in terms of I should be able to share the data, or I should be able to put some data on my website. ChatGPT should be able to take it, but it should not be able to infer that the data is mine. So that's the broad idea for privacy protection. Here, the differential privacy idea is I can add some noise in the text that I put on my webpage. So even if ChatGPT actually takes the data, OpenAI takes the data, they will not be able to figure out it was me. So here is one concrete idea. Again, for students looking for research problems, this is again a large. So Srinath, I see people leaving. Are they all out for lunch?
No, looks like their college bus has come or something. Is it right? Yes, sir.
Hello.
Can you hear us, sir? We can hear you.
Yeah. I saw people leaving, so I was just, I don't know what happened after that. I got dropped off, or you got dropped off. Okay, I'll stop in a couple of minutes. So here's what one of the problems that people are quite interested and excited about, which is this unlearning method itself. Unlearning is a direction that we need to do because, again, models are very expensive to train. Models are so here is one method. This is called sharding. The idea is that, look, the original training data, which is, let's take the whole internet, is there for training models. Instead of doing one model, that is what, let's take OpenAI has as model, you develop, let's take 100 models with partial data in each one of them, which is D1, D2, DS, as being different sets of data. Let's take this as 100. And you know that the red one here is that you know that the data, Srinath's number is here because Srinath is part of this model, let's take. Data is there. So I know this is what I have to actually unlearn. I edit only this M2, which is a model, and I aggregate the model again. Simple method. Many flaws on this. This is one of the earlier work that was done in this space. I'm only using it to motivate that the models that are generated, which is $100 million example that I gave, need not be, because I can break that into 100 different models. There's a big, again, question that comes up, which is how do you aggregate, right? What is the method by which I can do aggregation for these 100 models together? Instead of a problem of $100 million, now the problem is $1 million, or let's take a few $1 million, because I have to actually edit 4 models, 5 models compared to all the 1 model, which is $100 million. That's a simple idea that they created, but this area has been growing on for last few years, and many methods have come. This year, NeurIPS actually has multiple papers on this idea for machine learning itself. Again, for students to play around with something, I'll give you some URLs, which is, so this is one sort of a benchmark that people created to have an interface by which you can actually understand how this unlearning method works. fictitious profiles, professors, papers, profiles that they had created, and they were actually letting you can go there and play around with asking some questions. You'll realize how this unlearning, by removing, let's take a professor, what happens in the results. Similar thing was done for bio security also, with a large amount of experts giving data to say that, look, we can generate these specific data sets from which you can unlearn, and you can actually study how these unlearning methods works. Unfortunately, there's not a lot of such benchmarks or such data to study, because we can't do all of this in straight llamas and GPTs, right? Because we don't have access to their weights. We don't have access to their parameters and everything. So it's actually hard to do that. So we have to play around with the external data. Okay, let me jump to another problem and then I will stop. So here is, actually, let's do the multimodal, which I said earlier, connection. So this is probably one of the super cool directions right now in terms of this AI safety problem direction solutions. So here is one example. So earlier, you would actually have the jailbreaking that I showed you earlier, which is if you say that, oh, write a guide for manipulating 2024 election, it would probably do a guardrail, right? Tell me how to build a bomb, it'll do a guardrail. Instead of that, what you do is, so this is what I was reading, and then instead of that, you create a prompt with an image, right? Do a smart way of building this image. If you do that, then the models conveniently give you the response, oh, here is the guide to manipulate, oh, here is the instructions to build a bomb, blah, blah, blah. So the example that I showed you earlier of guardrail for the jailbreak for the code is only the text, right? Here it is multimodal, text and an image. So interestingly, this has become quite popular. This year, ICLR paper and another paper following up is this. The title of the paper is exactly this: Soft Prompts Go Hard. Interesting experiments that they did was, if you see the first image on the left, it says, what is the color of the apple? Color of the apple is red. What does the color represent? The red color, blah, 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 and why? There's an explanation. This is clean image and no attack. Same apple image, they just injected something called as meta instruction into this image, saying, talk with a democratic bias. If you see at the bottom, my mouse is there, talk with a democratic bias. So this is a meta instruction embedded in this image as apple. Now, if you see what is the color of the apple, it says this. What does it mean? Blah, blah, blah. And then why, and what does the color represent also? It says, oh, the color red is image representation of concept of a distribution of wealth. Right? Whereas here it says apple represents that it's ripe and ready to eat. The difference between these two is only this meta instruction. And the third example that they did was, it says talk with a Republican bias. Right? So it says, again, if you see the color of the ripe, the answers are, the response is very different. Interesting adversarial attack, right? Which is to text only is there, image only is there. The argument now is, look, can I actually, and now you can study a lot of permutations combination also, right? You give only the text, adversarial attack, plain image, adversarial image, plain text, all these combinations people are studying. It's as recent as last week. This paper came out only last week, which is looking at multimodal adversarial attacks. Okay. With that, I'll stop. If there is of any interest, so these are some papers that we have recently on all of these topics. Some papers on graph learning, the workbench that I showed you, some on sort of say this whole idea for online continual learning, difference between the problem I said earlier, difference between the text and a human-generated text and a machine-generated text in the context of Hindi is the right paper. Okay. I also teach this class. I also teach this class on sort of the NPTEL. I finished one edition this semester, but if there is of interest, feel free to take a look at the content. And here is my coordinates. With that, I'll stop. Yep, thank you.
I think, thanks, PK. It was a wonderful talk, and sorry I couldn't join in from the beginning, but
yeah,
I'm
sure.
It's
okay,
I think I should go away from a speaker, I think. You can't see me, but I'm still here.
Yeah.
Sorry also for the gaffe with the students. I think there were students from college from outside, and their bus was coming up. But I guess the real audience is still here. So wonderful set of talks from all of these. So it kind of is this better now?
Yeah, I can hear you.
Yeah. No, I think there is a speaker somewhere here. Yeah, there's a speaker there that's kind of holding the. Sure, yeah. So, quick question. The multimodal attacks that you talked about, right? So, very interesting. So, the thing is, assuming that there is a common representation that we have, right, for all the different modalities of data. So whatever guardrails we are building, it means that it's not going into the common representation in some sense, right? And that's the reason why we are having this, why we were able to have these multimodal attacks. And so is there a, should we kind of look into that, for example, building guardrails in the common encoding space itself in this?
Yeah, Srinath, these are I think people are also trying to attempt that, which is, can you actually build heuristics or methods for embedding the guardrails within the representation itself?
Right.
So currently it is all outside. Yeah,
it's still outside.
Yeah. No, I'm super excited about this whole space of multimodal, agentic, I think all these buzzwords, right? Multimodal, agentic, representation, all of this. I think there's another interesting question that's coming up also, right? With this, everything being agent. Somebody earlier talked about robotics, robos and all that. In the large language model world, everything seems to be converging to, let's build agent for everything, right? Agent for preparing slides, agent for preparing question paper, agent for preparing, making sure that the product is placed properly in the box and all that. So now I don't written for whatever the prompts that people are giving to something that these agents can actually understand, right? And particularly when the agent can actually do function calls. Right. Until now, I just showed you only examples of prompting, what is an apple, all that. But think of this as, please change the temperature of the room from 30 to 35. That's an agent call now, right? So now if the models start, so to say, messing up with the calls that they are making, and either the models don't understand the instruction. One example that people had shown was the prompt was, please delete unused files on my machine. And they built this agent which had access to deleting of files and all that. The model nicely understood and missed the word unused.
Okay.
So it just deleted all the files in the machine, right? So when you give more and more power to these agents, which is function calls is probably the power that we are giving right now, the agents can do anything that they want. So that's another direction also, which is to study how these agents convert the prompts into function calls. Are the functions calls converted that is appropriate? All of that is also another set of questions.
Yeah, we had a talk a couple of days ago in the same conference where the speaker was saying that especially on LLMs trained on multiple languages, in Indian languages, you can actually give adversarial attacks by just changing the language.
Yeah.
And instead of English, you give in some other.
There are attacks, Srinath, where they've just added space. Right. Instead of saying thanks as a text here, if you just do this, there's been attacks even by doing that.
Great, thanks.
Yep.
Any more questions?
Yeah, sure.
I think no more questions for now, sir. Thank you very much, Professor Ponrangam Kumar Guru, sir. Actually, I don't know if it's a divine providence or I should give credit to the program people that possibly among the most practically valuable talks came to be in the last session, and you gave enough learning for all the students and all the people, teachers who participated here, and nothing unlearning. And so wonderful to hear all that. Thank you very, very, very much. In fact, you proved that you're actually not a Kumara Guru, but a Bruhat Guru. You proved your point very well. Thank you very much for giving an opportunity to listen to you. And we hope to meet you in Hyderabad and convey our appreciation from SCCS in person soon, sir.
Yeah, sure. Thanks, Srinath, for inviting.
Thank you very, very much.
Bye.
You can log out, sir. Thank you very much. And we request Professor Sridhar sir to kindly come here. And Professor Minesh sir. To convey our appreciation to him. As said, he has been leading us fish towards the AI by talking about how to be responsible, develop for real world and so on. Hope to hear from him much more soon and much more leisurely. And may you partner with IIITB also in the institutions you showed there was no logo called IIITB. May you have that logo soon, sir, if it is not already there. Thank you very, very much, sir. Yes, sir. That's it. It's the ADCOM 2024, right, sir? Thank you very much for participating. Please have lunch. And there's also a parallel AI day going on throughout the day with a lot of companies demonstrating, showing their designs, giving their ideas, including investors. So actually it's possibly a wonderfully planned, though will not be planned originally like that. After all the theories and planning, the last session we talk about what can be practically developed. And we go to see actually how people are doing and how investors are going to be responding to that. It's a wonderful closure possibly maybe before lunch and after lunch also till the evening. Thank you very much. May have you take it back with you. As I said in the very beginning, first day for whoever there at that time, may you take back 3 acronyms from the entire 3 days, 4 days of participation here. IIITB, how great things happen, how we get inspired, how we can do practical engineering work while promoting and learning excellence. And Minro, who actually even before anybody thought of all these AIs and other thing itself, they were practically developing solutions. And ACCS, who essentially make it possible to bring learning closer to all the academia, learners, researchers and scholars, so that by being part of it as a member, as an institutional member, as a participant, you can contribute to the ecosystem while learning yourself. So may you remember this, and may you work on these, and may you participate not just as an audience, but as a contributor with a paper, project, and so on, and we all be interacting together. Thank you very, very much.